Hello friends, I am your chemistry faculty from QLS Academy. Today we are going to learn about non-metals and how metals and non-metals react with each other. Hope you will enjoy today's class. Now let's get started with our today's lesson. In last class, we learned about physical and chemical properties of metals, how metals look, how can we identify metals from other substances, and how metals react with most commonly encountered compounds like water and acids. For today's class, first let's see the physical properties of non-metals. Non-metals, unlike metals, don't have a shiny surface. They have a dull appearance except for graphite, diamond and iodine crystals. Graphite and diamond are just two different forms of non-metal carbon. कार्बन जो कि एक नॉन मेटल है उसी के ही दो फॉर्म्स है ग्रेफाइट एंड डायमंड. दे आर कॉल्ड द एलोट्रॉप्स ऑफ कार्बन. नाउ as opposed to metals, non-metals are very brittle and cannot be rolled into wires or pounded into sheets. Means they are non-ductile and non-malleable. Also, they do not produce sound when hit. Instead, they break as they are brittle in nature. Also, non-metals cannot conduct heat and electricity except for graphite. The graphite used to make lead of your pencils can conduct electricity. And lastly, unlike metals which majorly exist in solid form with mercury as the only exception, non-metals exist in all three different states. Carbon, phosphorus, sulfur, selenium and iodine are the solid non-metals. Nitrogen, oxygen, chlorine, helium, neon are gaseous non-metals. Whereas bromine is the only non-metal found in liquid state. The boiling points of non-metals lie below than that of metals. जो नॉन मेटल्स होते हैं उनका बॉइलिंग पॉइंट मेटल्स से कम होता है. बट द मेल्टिंग पॉइंट ऑफ डायमंड इज क्वाइट हाई एज दैट ऑफ मेटल्स. Diamond, an allotrope of carbon, melts at temperature even above 4000 degrees centigrade. Melting of diamond is not an easy task. Now, let's give a quick recap to the physical properties of non-metals. Non-metals have a dull appearance. Non-metals are non-malleable. Non-metals are non-ductile. They are also non-sonorous. Non-metals cannot conduct heat and electricity except for graphite. Non-metals exist in all three different states, that is as solid, liquid and as gas. Now, let's see how metals and non-metals react with each other. Metals और non-metals के बीच में interaction कैसे होता है, उनके बीच में reaction कैसे होता है. First, some questions. कोई भी एलिमेंट या कंपाउंड रिएक्ट क्यों करता है? Why does any chemical reaction occur? Why elements combine with each other to form compounds? Answer to all these questions is the same. Elements and compounds react to fulfill their valencies. Elements and compounds अपने अपने valencies को complete करने के लिए आपस में react करते हैं. Atoms combine with atoms of same type or of different types to fulfill their valency. To have a complete octet, some elements can have a complete octet with 8 electrons, while some can have it with only 2 electrons. So, to have a completely filled valency shell, atoms and molecules of elements and compounds react with other atoms and molecules. Here, you can see the electronic configuration of noble gases. Each of them have a complete octet. Hence, they don't need to react with other atoms for the completion of their octet. And that's why they show a very little or no chemical reactivity. Now, let's check the electronic configuration of some metals. Now, here you can see the metals have 1, 2 or 3 electrons in their outermost shell. Like sodium and potassium has only 1 electron in its outermost shell. Magnesium and calcium have 2 electrons, while aluminium has 3 electrons. Now, to complete their octet, these metals can either bring in some electrons in their outermost shell to make the total count equal to 8, or they can lose the electron from the outermost shell to reveal they already fulfilled the second innermost shell. Let's take example of sodium. Sodium has an electronic configuration of 281, means in its valence shell, in shell M, only 1 electron is present. इसके outermost shell में सिर्फ एक ही electron present है. So, to have a complete octet, sodium needs 7 more electrons in its outermost shell. But if it loses 1 electron from M shell, then shell L will become the outermost shell with an already completed octet. 1 electron lose करना ज़्यादा easy है than gaining 7 electrons. But this doesn't come for free. Everything has its own charge. Loss of an electron reduces the count of electrons in a sodium atom. Sodium atom में natively, initially 11 electrons and 11 protons present रहते हैं. Means equal number of negative and positive charges. But as it lost 1 electron, the balance of the positive and negative charge got disturbed. Now a sodium atom have 11 protons but only 10 electrons. Means 1 extra positive charge. And that's how sodium cation is produced. And क्योंकि सोडियम आयन में पॉजिटिव चार्ज ज़्यादा होता है, so we represent it as Na positive. Same happens with other metals. Now let's see the electronic configuration of non-metals. Here the gain of electrons is more convenient than losing electrons. यहाँ पे electrons gain करना ज़्यादा easy है than losing. For chlorine, for example, it would be easier to gain 1 electron instead of losing 7 electrons. Gaining of electron also disturbs the positive and negative charge balance. Initially, a chlorine atom possessed 17 protons and 17 electrons, but with the gain of electron, it became 17 protons and 18 electrons, an extra negative charge. This gives the negative particle, chloride anion, Cl negative. Imagine a scenario where sodium and chlorine atoms are moving freely. Now suddenly the atmosphere becomes tensed. Each atom is trying to complete its octet. Sodium atoms are losing electrons to complete their octet, while chlorine atoms are searching heavily for electrons to complete their octet. Then chlorine atoms encounter the electrons lost by sodium and readily takes them in to complete their octet. We can represent this by the following equations. Now, जहाँ पहले सोडियम एंड क्लोरीन एटम्स मूव कर रहे थे, वहाँ अब सोडियम कैटायन एंड क्लोराइड एनायन मूव कर रहे हैं, बट नॉट फॉर लॉन्ग. एज यू ऑल नो, पॉजिटिव एंड नेगेटिव अट्रैक्ट ईच अदर. Sodium and chloride ions being oppositely charged attract each other. So, a strong electrostatic force of attraction gets established between them. Sodium and chloride ions get bound to each other by ionic bond, a bond which exists between ions. आयंस के बीच में जो बॉन्ड एग्जिस्ट करता है, जो केमिकल बॉन्ड एग्जिस्ट करता है, उसे हम कहते हैं आयोनिक बॉन्ड. इन अ क्रिस्टल ऑफ सॉल्ट, सोडियम क्लोराइड do not exist as a molecule but rather as a cluster of oppositely charged ions. A single sodium ion is attracted to several chloride ions and vice versa. But since the ratio of sodium and chloride ions is 1:1, the unit formula of sodium chloride is written as NaCl. These type of compounds, which are formed by the complete transfer of electrons from a metal to a non-metal, are known as ionic compounds or electrovalent compounds. Now, let's check the different properties of ionic compounds. First is their appearance. Ionic compounds are hard solids because of their strong force of attraction among the ions. The stronger the force of attraction, the harder will be a substance. They are also brittle. Under applied pressure, they break into pieces. Due to strong attractive force, the ions are held together very strongly. This also results into high melting and boiling points of ionic compounds. High amount of heat has to be applied to overcome the strong interionic attractions. Magnesium chloride melts at 713 degrees centigrade, while sodium chloride, the common salt, melts at 800 degrees centigrade, whereas calcium oxide melts at 2571 degrees centigrade. Next property is their solubility. Most ionic compounds are soluble in water. When ionic compounds are dissolved in water, they dissociate into their respective ions. Same thing happens when ionic compounds are melt. This gives rise to next property, that is conductance. क्योंकि ionic compounds अपने molten state and solution phase में अपने अपने charged particles release कर देते हैं, they can conduct electricity. Ionic compounds molten and solution phase में electricity conduct कर सकते हैं, but solid phase में possible नहीं है, because the ions are held by strong forces of attraction which don't let the ions move. So, in liquid state, the ions dissociate and move towards the oppositely charged poles. So friends, this was all about non-metals and their interaction with metals. Hope you all enjoyed today's class. If you have any doubt or need any further information, you can visit the following link.